Right, in today's lesson, we're going to talk about identifying proportional relationships. And we're going to do this with a visual aid or a graph. So in the beginning of our little story here, it tells us another way to determine whether two quantities are proportional, that means two things that we're measuring, is to graph the quantities on the coordinate plane. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. So basically, in order for anything to be proportional, the way it should look on a graph is that we have our coordinate plane here, and it's a line that can come from any direction, but absolutely must intersect somewhere through the middle or the origin. It can go that way, it can go that way. It doesn't really matter. It could be really, really, really steep. It could be really, really, really narrow. It doesn't matter. As long as it goes to the middle here, then it's proportional. If it goes anywhere else along the x or y axis, then it's not proportional. And we're going to see that in some examples here. So in example 1, it says the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. So that's a rate we're going to need to know. Determine whether the number of feet the sloth moves is proportional to the number of minutes. So we want to know about the number of minutes it moves by graphing it on the coordinate plane. Explain your reasoning. So what they give us here is a table. And it says, make a table to find the number of feet walked for 0, 1, 2, 3, 4 minutes. So here's our graph. Here's the time they're talking about, all the minutes. And we know that it moves at 6 feet a minute. So that is our unit rate, 6 feet in 1 minute. So then if that holds true every single time, then 6 feet in 1 minute, 6 times 2, 12 feet, times 3, 18, times 4, 24. If it's always consistent like that, then we know we have a proportional, we have two quantities that are proportional. There we go. And also it says here, if he's not moving at all, if no time has passed, he doesn't move at all. That makes sense. And those coordinates represent the origin. So before I even make a graph, I can see that because it has these 2 points, 0 and 0, that it absolutely crosses through the origin. And here we have a nice little graph. As always, whenever you make a graph and you're measuring something against time, time is like 99% of the time going to always be the bottom part of your graph, the x-axis. Whatever else you're measuring it against will be the y-axis, in this case, the distance. So the sloth, when time is 0, when time is not moving, it's not moving either. And after 1 minute, it's moved about 6. Well, it's moved exactly 6 feet. And then after 2 minutes, 12. After 3, 18. The graph's a little fuzzy here. And so on and so forth. And we get our straight line. And if you look, you can see that this straight line, if we had the rest of our coordinate plane, would go through the axis. Well, obviously you can't have negative distance. That's why we don't see anything over here. But it is a line that goes through the origin, or at least intersects in this case. So let's go ahead and move on and see what you remember or what you know about this. Go ahead and work on this got it problem, and then we will discuss it in class to see if you did it correctly. All right, so now we are on page 161, and I'm looking at example 2. The problem reads as following. The cost of renting video games from Games Incorporated, or Inc., is shown in the table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane. Explain your reasoning. So here they give us a nice little data table, and let's look at what it says. It says the number of games, the cost in dollars per number of games. Well, right here, once we have the number compared to 1, we know we're automatically going to have a unit rate. And once we have a unit rate, that's a good first sign that we're going to have a proportion going on here. Two quantities that are proportional. But that's not always, it doesn't mean it's necessarily going to happen. It just means it's a good sign. So it's a place to start. So I would suspect that if it costs $3 for one game, then 2 games would be $6. And that's not what I see here. Well, let's keep going. $3 for 3 games should equal $9. And I don't see that here either. We should have a 6, we should have a 9. 4 times 3 would be $12. And I still don't see that here. So I'm already questioning whether or not this is proportional. Let's go ahead and make a graph just to make sure. Well, here I see that here's the data. $0 means 0 games. We're not at 0 games. Look, we already have a point here. 0 games are being charged about $1. How can you be charged for not even renting a game? Already I can tell this doesn't make sense and it's not proportional. Also, another way to always check your answer if you're still not sure is to look at the ratios. We have $3 for 1 game. Is that equal to $5 for 2 games? And to $7 to 3 games? And $9 for 4 games? 3 to 1 can't be simplified. 5 to 2 can't be simplified. 7 to 3 can't be, and 9 over 4 can't be either. None of these are equal to each other, and none of them simplify into anything else that looks remotely like each other. So I know these are not proportional. So using that kind of reasoning, well, before we move on, let's look at this quick review. When drawing a graph, include a title and labels for the horizontal and vertical axis. That's a really good point that you guys need to remember, because if you don't know what you're measuring, then you won't know how to graph it. And conversely, we could give you a graph maybe where these two things are flipped, and in which case you'd still get a line, but it would look different. And if you're not paying attention, you could actually make a mistake in understanding what the graph is telling us. So it's very good to always read your labels in a graph before you start dissecting it, so to speak. So let's go ahead and move on up to the got it. And I want you to go ahead and work on these on your own or with your group. If you have any questions, please feel free to raise your hand, and we'll see what we can do to help you. After this, let's go ahead and we'll move on to the next page. All right, finally, here we are on page 162, and we're going to look at example 3. It says, which batting cage represents a proportional relationship between the number of pitches thrown? So let's go ahead and kind of underline that, because that's important. Pitches thrown and the cost. So we should have pitches thrown, which is just a number, and the cost, which will be measured in dollars. So here we go. 0 pitches up to 13. And it says here, the graph for softball plus is a straight line, but it does not pass through the origin. That's a good first sign right there, telling us what we have. So the relationship is not proportional. That makes sense. The graph for the fun center is a straight line through the origin. Very important there. So the relationship is between the number of pitches thrown and the cost is proportional. So and that's obvious right here. This line goes right here through the origin. This one cuts up here through the y-axis, somewhere above 0. If I continue my axis, that's what it would look like. Remember, anything that's proportional when graphed has to pass through the origin here at 0, 0. If you have a 0, 0 relationship where 0 things happen for 0 amounts of something else, then you have a proportional relationship. Over here, apparently, look at the number of pitches. If we have 0 number of pitches, we're being charged $3. That doesn't make sense. If you're not doing anything, you shouldn't be charged anything, really. This must be like a service fee just for walking into the place. Whereas here at the Fun Center, if you don't do anything, you don't get charged anything, and that's a little more fair, I believe. So now go ahead and work on the rest of the assignment for your homework.